So today, as Ken said, we will be talking about mobility. So I'll be kind of like dividing my presentation into different parts. First, I will be giving more of an overall overview of mobility and high-level ideas, how we see mobility in the group. So that's kind of like the goal of this first presentation. So kind of as you may know, if you think about the past of the cities, for many, many years, cities were this kind of human-centric hubs of innovation where people were living and working in a walkable distance. And you see streets, for example, in this video of Barcelona, where people were walking, biking, interacting with each other. So there was kind of this vibrance in the streets. And in less than 100 years, with the introduction of the car, there is this dramatic shift in urbanism where cities start to be designed around cars and not longer around people. And then kind of we see these streets that become full of asphalt, parking spaces, and cars, right? So there is like that change. And the kind of unintended consequence of this is that we have gotten to have cities that have polluted air, are full of traffic noise, where we spend kind of like countless hours stuck in traffic congestions. And then there is like the other side of the problem, which is like the sustainability impacts that this has. Mobility is one of the biggest contributors to CO2 emissions, and in particular in the US, it represents 29% of the total emissions. And then if we see within transportation, about 60% are coming from light-duty vehicles and pickup trucks. This is like mostly like passenger cars. And what I think is like even more alarming is that the transportation-related emissions are increasing. So we have seen mainly a decrease in all of the other sectors. And this has been like the sectors with the largest growth in CO2 emissions since the 90s. What I think is interesting also is that there was like a decrease in fuel efficiency actually between the 90s and 2004, because even if the motors were becoming more and more efficient, people were buying bigger and bigger cars. So there is like this effect that is called like SUVification of the fleet. So we like bigger vehicles, pickup trucks, and so on. And this has also partly been driven, like the rest of the increase in the emissions has been driven by economic growth, population growth, urban sprawl, some periods of low fuel prices, and so on. So this is kind of where we are at that, now. And there is part of the narrative that is like, okay, but we have electric vehicles, and electric vehicles will solve kind of like all of our mobility problems. But the reality is that the truth is a little bit more complicated than that. And if we really think about how mobility emissions are generated, it's actually like a more complex scenario where there is like different layers to it. First, there is like the population side that we have. Then we have to take into account, on average, how many miles do people travel. Then we have to consider like the vehicle in which they travel, like how much energy does it require to move you for 1 mile. And lastly, we have the last aspect, which is like the carbon intensity of the energy that the vehicle is using. So it's like a much more multifaceted kind of challenge that we have. So if we think that population is something that like we cannot alter, we are actually left kind of like with three different levers to act upon. And the way that we are thinking about this at City Science is that if we want to reduce mobility emissions, we could, for example, reduce the miles traveled per person by increasing, like, encouraging more like high-density areas, more walkable districts, where essentially you are reducing the distance that overall the population is traveling. Then there is another aspect of it that is like switching from cars and bigger vehicles to more lightweight and sustainable vehicles, such as bicycles, tricycles, and as you will see later in Michael's presentation, this can be autonomous as well. But the idea is that a lot of the trips that would remain in high-density areas are single-person, low-speed, short distance, and then cars don't make a lot of sense in that context. And lastly, there is like the last layer of like electrifying the cars and decarbonizing the grid. So that's kind of like the different kind of like types of interventions that we can think about. What I think is interesting to understand is not only like which levers do we have, but also how much do we have to act upon each one of these levers to get, for example, to meet like the 80% reduction of carbon emissions by 2050. So there is a very interesting paper that I'll refer to right now that gave kind of like a set of answers to this question. And I'll just highlight one specific scenario to give you an idea. What this says is that even if we had zero carbon energy by 2050, which is already challenging, we would still need to eliminate all the miles traveled in the 10 most densely populated areas in the US and still electrify 50% of the fleet. what I'm saying with this is like, there is a lot of conversation sometimes in the field of transportation. It's like, is it about electrifying the vehicles? Is it about kind of building more walkable cities? And I think it's like a combination of both, and we actually have to be very ambitious in all of the aspects that are related to decarbonizing mobility. And just as a quick exercise of like thinking what it would take to, for example, Boston is one of the 10 most densely populated areas in the US. So as a thought exercise, we can imagine what it would take to actually like have 0 vehicle miles traveled in Boston. So this is a graph that shows all the miles traveled by different modes. So you can see that 70% of the miles are traveled by car, 0.5% of the miles are traveled by bike, 1.5 are done walking. You might have seen other numbers because the mode split is bigger, but if you look at it in distance, usually like the walking trips are very short. So that's why you see like this like higher proportion of vehicles driving, even in a city that it's a little bit more walkable than others. So if we focus on the car trips, we can see that there is kind of like, as I see it, like 2 different behavior types. There is like the trips that are above 5 miles, which is like, for example, not a reasonable distance for walking, right? And those represent 90% of the emissions. So there is like the trips that are longest represent most part of the emissions. And for example, to eliminate something like this, it's very related to having walkable districts, like more like of the ideas related to 15-minute cities and so on. Whereas once that you have that, the trips are going to be below 5 miles, and just maybe like, I think like it's interesting as a fact that 42% of the trips are below 5 miles, and actually 7% of the trips are below 1 mile. And those numbers are for Boston, but it's very similar across the US. So the other idea here is like for shorter trips, you can actually encourage mode shift. So as I said, like this is still like pretty high level, but some of the key ideas that you can get is like transportation is the biggest contributor to greenhouse gas emissions in the US, and it's increasing, and throughout the world it's also like usually number 1 or 2. A vast majority of it comes from personal passenger vehicles and pickup trucks, and then some of the actions that we can take are we can eliminate long commute distances by having like more walkable cities. We could then also think about shorter trips, having like this mode shift towards more sustainable like mobility modes like walking, active modes, etc. And then there is like one aspect that is about making the systems more efficient. So for example, if we travel by car, but the cars are shared, for example, we could have lower emissions, etc. And then there is like a last layer that is about having like more lightweight vehicles, electric vehicles, decarbonized grid, etc. So this is overall how we often see mobility in the group. And I'm going to just briefly explain like how this relates to our specific research, because that you will see like different aspects of it throughout the class. So there is one leg of it that we do think a lot about walkable cities that encourage active mobility, but this is not what we will see in this class. That's very related to a tool that you will see later on in the course that is called the Cityscope, that is more focused on urban planning. So this will be seen in other lectures. What we do also in terms of mobility, and Michael will be speaking about this, is design new mobility modes and prototype them. So for example, you can see here the PAV and the autonomous bicycle project, where the idea is that you can request a ride on demand, but instead of getting something like an Uber, for example, you get a more lightweight and sustainable mobility mode that drives autonomously to wherever you are, but then you pedal like a regular bicycle or tricycle to your destination. So it's like kind of like a semi-autonomous solution. So Michael will show especially like his work in terms of developing the PAV in the group. And then the last layer that we do that is related to these new mobility modes is not that we not only like prototype them and build them and take them to the street and see how they work, we also do a lot of simulation and modeling that tries to understand like what would be like the fleet level implications of this. For example, what are the sustainability impacts, who is going to use this, what's the efficiency that we need in the system, how many do we need, and this is a little bit what I will be talking about in the second part of the presentation.